Hi everyone, hope all of you guys are doing well. And this is the homework for our first chapter, which is chapter 16, and it is kinetics. Okay, so the first question. So by now I hope you guys have watched all the videos posted for chapter 16. So with that in mind, I will go ahead and explain you how to do some of these questions, so you should be able to complete the homework assignment. Okay. The compound Rx3 decompose according to the equation 3Rx3 and given, right? So in an experiment, the following data were collected for the decomposition at 100 degrees Celsius. What is the average rate at which Rx3 is disappearing over the entire experiment? Now, when you say average rate, that means from 0 to whatever the time that the experiment has been run, we have to take the data into consideration. Basically, there are three rates we normally determine from a graph. It could be initial rate, average rate, and instantaneous rate, and we talk about this during our lecture. Now, since this is an average rate and the time runs from 14 to 0, so the rate is going to be like this. Rate could be rate equals delta, your reactant, in our case this is Rx3, change in concentration of Rx3 over the time period. It is asking disappearing over the entire experiment. So normally if it is the reactant, it is negative. So it is given in the wording, it's disappearing. So it is going to be negative, but we don't have that negative in our answer since it's already saying that it is disappearing. Okay. So what is the change in concentration over time? That's going to be negative 1,6. That's the final concentration, right? At 14 times 14, and then at the beginning it's 0.085. So 0.85. Final minus initial and delta t. What's the delta t? Is a time duration from final to initial. Final time is 14 seconds and initial is 0. So that's the time. So 0.16 minus 0.85. What's that going to be? 0.16 minus 0.85, negative 0.69, negative 0.69 over 14. So that will become positive over 14, that is 0.049. Okay, excuse me. So that's going to be your average rate. Okay, all right, and then so you're going to find out the answer for this division, and then you write down the correct answer. Number 2, consider the following reaction. If C is increasing at the rate of 4 moles per with the units, at what rate is B changing? Now, how are we going to perform this reaction or this question? Let's see here. Now we are given 8A plus 5B, giving you 8C and 6D. So how do we represent rate? Remember, we learn in the lecture we can represent the rate for a reaction like this. Okay. So the rate can be expressed in the general form. Rate equals, now this is our reaction. We can write the rate for reactants as well as for the products. When we write the rate for the reactants, since the reactants are going to diminish throughout the experiment, the value or the sign going to be negative. So that would be negative. And for when you write it for the A, remember the coefficient has to be go to your denominator, 1 over 8 delta, and then we have A, your reactant, over delta T, which is also similar to the rate of disappearance of B, which is now again negative since it's a reactant, and the coefficient 5, it goes to the denominator, 1 over 5 delta B over delta T, which is also similar to the rate of appearance of C and D. Now, since C and D are going to be more than what we started with, it is positive for the products, right? So it would be 1 over 8 again for C equals 1 over 8 delta C over delta T, which is equal to 1 over 6 delta D over delta T. Now this is the rate for all 4 components, for your 2 reactants and for your 2 products. Now it is asking if C is increasing at the rate of 4. So C going to be this one right here. We are given the rate data for C. Increasing at the rate of 4, what rate is B changing? So we are going to incorporate that with B. These two, right? What rate B is changing, concentration of B is changing. So we're gonna compare these two together. So rate of B, so let's take 1 over 5 delta B equals, delta T equals 1 over 8 delta C over delta T. What we want to find out is this. What is the change of this? Then, so this 5, we have 5 here. So we want to, so you basically multiply the whole thing by 5. So you can get rid of this 5 and you move to the other side. So that will make it 5 over 8. And we are given that the increase at the rate of 4 over here. The C concentration is increasing, meaning this part, delta C over delta T is 4. So you put that 4 right here. Okay, so I hope everybody got it right. So the way that I'm explaining it to you. So the rate of the C is given is as 4, and then we initially write the rate for all the reactants and the products, and then we got the 2 that we are going to compare, and we want to isolate this part. This is what we're trying to find out. And then we also got rid of 5 from this side and move it to the other side. So with that we got this calculation where we can do 4, 2 and 5 over 2 is, what is 5 divided by 2? 2.5, right? So the rate of decrease of B over time is 2.5, and it is also negative because it is a reactant. So the answer would be yes, negative. So we are looking at number 2. I was looking answers in number 3, but we are still at number 2. Okay, so that would be negative 2.5, right? So negative 2.5 moles per liters per second. So that's how you would answer a question like that. Okay. Okay, and number 3 also similar to that. I'm going to go ahead and erase this information here, so you guys can, so I can go ahead and write in the same space. Okay, you can write this down in a separate piece of paper, so you have it in front of you when you study. Okay, and now let's look at the other question, the next question, which is number 3, which is also similar to what we did right now. Consider the general reaction. So we have this reaction given. For this reaction, the rate when expressed as delta bromine over delta T is the same as, so it's going to relate to Br minus and bromate and water. Let's see which one going to be the correct answer. So let's take this one. So bromine, we are going to compare this with the other ones. This one. So because of that, let's go ahead and write down that one first. Delta Br2 over delta T. But when you write the rate, bromine is right here, Br2. So it has a 3 at the front as a coefficient. So it should be something like that, 1 over 3. And this is the rate, and this is positive, right? Because rate is positive because it's a product, 1 over 3 delta bromine over delta T. Let's go ahead and compare that with the bromide, because the first choice is bromide, Br minus. Where is Br minus? Right here. So if you compare that with that one, it's going to be negative 1 over 5, right? And why negative? It's because it's a reactant. Remember, always for the reactants, it's going to be negative, Br minus over delta T. Now we try to isolate this part. This is what we are going to compare. So then that part would be, now here we have a 3. So this 3, now we need to get rid of. Basically you multiply the whole equation by 3. So that would be negative 3 over 5 delta Br minus over delta T. So what is 3 over 5? It's 0.6, or negative 0.6 delta Br minus over delta T. So negative 6 delta Br minus over delta T. So we got the answer right away. So that's the correct answer. But let's go ahead and see why the rest of the answers are not the correct one. Right? We got lucky. It was the first one is the correct one. But let's do the other ones also and see why the next one is the not correct one. Okay, again I'm going to go ahead and write down 1 over 3 delta bromine over delta T, bromine concentration. Now I'm going to compare it to bromide again. And we found when we did that calculation, which we did right now, it's 0.6, right? It's not negative 5. So this one, these two and these two are the same. So we found it is negative 0.6 is the correct answer, not negative 5, right? Negative 5 is right here. But it is 1 over 5, but you have to multiply it by this 3 over here. So the correct answer is that. So we don't even need to do the calculation again to find out that the second choice is not the correct one. We already found the answer with regard to Br minus and delta T. But bromate we didn't do. We can do the bromate one. Okay, so let's try to see. Now I'm looking at this one, if that is the correct one. So I'm going to compare delta bromine over delta T equals bromate. Where is bromate? Right here, which is a reactant. So then it has to be negative delta BrO3 concentration over delta T. And we don't have any coefficient, so you just write it like that. But bromine, this one here, we have a 1 over 3, right? So with that in mind, so then the bromine over delta T going to be delta bromine over delta T. So this 3 should go to the other side. That would make it negative 3 delta BrO3 over delta T. So the correct answer for C would be negative 3 delta bromate over delta T, right? So why C is not correct? It has to be negative, but we don't see the negative ones. Other than that, answer C, 3 times bromate over delta T is correct, but we are missing negative part. So because of that, that's not the correct answer. Okay. Now let's look at the other one, the last one. Why that is not the correct answer? Again, 1 over 3 delta Br2 over delta T equals, with respect to water, where is the water? Is one of the products, so it's positive. So 1 over 3, remember the coefficient goes to the bottom, delta water concentration over delta T. So then if you're going to represent it like this, there would be delta bromine over delta T equals, now we need to get rid of this 3 goes to the other side, 3 over 3 delta water over delta T. So it would be water over delta T, right? So we have the correct formula, but it has to be positive. What's given here is negative. So because of that, D is also not the choice. So the correct answer is A. Okay. Hope you guys understood how we came up with the answer. Wonderful. Okay. The next one. Consider the reaction. If the rate delta H2 over delta T is 0.03, then delta ammonia over time. Similar to what we did before. You guys can do this one without my help, but let's see. If you are comfortable, you don't have to, look up what I'm doing. You can go ahead and work yourself. But I'm going to go ahead and show you this one as well. If the delta H2 over delta T. So let's go ahead and compare this guy with this. That's what it is asking. We see H2 over delta T and ammonia over delta T. Let's go ahead and write the rate for these two things. Rate would be for hydrogen 1 over 3. Okay, 1 over 3 delta hydrogen over delta T. Is it positive or negative? Because it's a product, it's positive, right? Rate. And then for ammonia, that would be negative, right? Because it's a reactant. 1 over 2 delta ammonia. That should be N. Delta ammonia concentration over delta T. The rate delta H2 over delta T is 0.030. Here 0.030, meaning this one is 0.030. So what we want to find out is what is the concentration of ammonia over delta T. So this is what we want to find out. So then that would be negative delta ammonia over delta T would be, so here you have a 2, so you can multiply it by 2. So 2 over 3. So I'm take this 2 into the other side, 2 over 3, and delta H2 over delta T is 0.03. So you substitute it over here to 0.03. Okay, so 3.01. 0.01 times 2 is 0.02, and it has to be negative. So negative, since we have a negative here, negative 0.02. So the correct answer would be negative 0.02. Okay, so that's how you would answer that question. Okay. All right, I'm going to go ahead and erase it so I can have some space to do the next question. Oh, I didn't have to erase this all. Okay, fine. Okay, the next one. The following data were collected at constant temperature. Determine the correct rate law for this reaction. We did bunch of examples like this in our lecture videos also. So you should be able to do it. But let me go ahead and help you. So here we are trying to figure out what are the orders with respect to A and B. And our reaction is this. Right? So when you write the rate law, how would you write the rate law? For a general reaction, rate equals K is the rate constant and one of the reactants A, and so the coefficients 3 and B are not the rate orders, so they are just the molar ratios. So we need to figure out the orders. We're going to represent them as M and N. So A, and for the B there would be N. Now our goal is to find out what is M and what is N with the given data. Okay. So we're going to keep one of the concentrations constant and keep the other varying. Now if you take 1 and 2, we have initial concentrations of B remains the same, 0.1, 0.1, and concentrations of A is changing. And then these are the rate data for both. So we can either divide 1 over 2 or 2 over 1. So when you are going to divide, we're going to see which one has the highest number, and then you divide by the lower one. So looks like we can do 1 over 2, rate 1 over rate 2, right? So you do that, rate 1 over rate 2. So for the rate constant, K, and concentration of A, 0.2 m, concentration of A in rate 1.1 m, and then the concentration of B for rate 1.1.1, and since they are the same rate, they're going to get cancelled. So rate 1 is 6 into 10 to the negative 2, rate 2 1.50 into 10 to the negative 2. And rate constant, since they are at the same temperature, they're going to get cancelled. So 0.2 over 0.1 is 2 raised to the power m. So 6 over 1.5 is 4. So 4 equals 2 raised to the power m. So then the m is going to be m equals 2, right? So because 2 times 2 is 4. So m is 2. And if you don't see this right away, you can use the log term. Remember, we learned about the log. So you can use m equals log 4 over log 2. So log 4. What is log 4? If you calculate log 4, you can do it in your calculator. Find out what is log 4 and let me know. Okay, so that's 0.602 over log 2.301, which is again 2. Okay, so you can find m like that. So we found the order with respect to A, which is 2. So now we're going to do the same thing to find out the order with respect to B, concentration. Okay, I'm going to go ahead and erase this part over here so I can have more space. Now we are going to do the same thing, but this time we're going to choose 2 different rates where we can keep concentration of A constant. Okay, so what do you think we should use? Concentration of A constant and concentration of B changes. So we can use 1 and 3. See, 1 and 3, where concentrations of A going to be constant and B changing, and we take these 2 data. So what are we going to do? We can do 3 over 1 because 3 has a bigger number compared to 1, right? So rate 3 over rate 1. That's what we are going to divide. So rate 3 is 1.20 into 10 to the negative 1 over 6 into 10 to the negative 2, and K is the rate constant, concentration of A 0.2, and then concentration of B also 0.2, that is N, and which we find already M is 2. Concentration of A in rate 1.2 and concentration of B in rate 1.1 N. So this cancels, rate constant cancels, 1 over 1.2 over 6 is 2 equals 0.2 over 0.1, 2 raised to the power N. So N equals 1. So we found the orders M equals 2, N equals 1. So now we can write the rate for the reaction. That would be rate is K, A, second order, and B. So that you can find out the correct answer. Okay. And I will stop this part here because my videos has to be less than 30 minutes for it to upload to the YouTube. I will explain the rest in the second video. Okay. So bye for now.